Hey guys, 9-2, to be honest, isn't doing anything new, okay? First, so we're not going to go into a lesson per se. I'm just going to go over each section of the homework. A few chapters ago we talked about linear scatter plots having a positive correlation, a negative correlation, or no correlation, and then determine which R value is more accurate. Okay, remember, R value is correlation coefficient, and your calculator calculates for that for you, thank goodness. And the first 6 questions are just multiple choice. I also gave you a half sheet today which explains correlation coefficient and reviews it, but basically the idea is the higher your correlation coefficient is approaching 1 or -1, the closer your data is to being a perfectly straight line. And as it gets closer to 0, that means that your dots are more scattered, and when it gets down pretty low, then that's going to mean that it's very scattered and there's no linear relationship there, okay? There might be another kind of relationship. It might not be scattered, but it might not be a line. It could be quadratic, it could be exponential, but it's not a line, all right? So the first section wants you to choose which correlation coefficient seems the most reasonable and say where it's positive or negative. Well, I'm going to have you do something a little bit different. Certainly find the right choice, but next to every wrong choice, I want you to say why it's wrong. For example, B and D are the wrong sign. These dots are going up. They're increasing. They should have a positive R value. So I wrote the wrong sign next to it to say why it's wrong. So I was left with an R value of 0.8 or an R value of 0.08. Well, just looking at this graph, an R value for this should be pretty close to 1 because those dots are pretty tight. They're getting close to that straight line. And certainly 0.08 is very, very low. Well, that would be, I mean, to the eyeball, you would not see any pattern of going up at all. You wouldn't be able to even see that. So that's a very weak correlation. And this is a strong correlation. Okay, so next to each choice, you're going to write why it's wrong, and then circle the right one. Okay, so that's 1 through 6. All right, 1 through 7, holy shnikes. Okay, again, here is the book trying to convince us that we need to do these complex calculations by hand, and no, we don't. This is correlation coefficient by hand. These are all the steps your calculator does to determine your R value, and that is crazy much work. Well, we're not doing that, okay? First of all, if we want our calculator to do this for us, we have to go into Stat Diagnostics and turn our diagnostics on. This is found in the mode key. Hit the mode key. The mode key is right here next to second. You're going to hit that and turn your stat diagnostics on. The default is for it to be off. Anytime you reset the memory, it's going to turn it back off. Okay, so that's the first thing. If you don't do that, your calculator will not calculate R value for you. Okay. Secondly, we're going to here. We're putting these data coordinate pairs into our calculator just like we did yesterday in 9-1. So 3, 5, and 10 are both all X values, and 2, 7, and 9 are all Y values. So I'm going to put those in the L1 and L2. All right, then I am doing linear regression. Now in this section from 7 through 12, it's not asking you to write the linear regression equation. All I am taking off this screen is the R value. That's it. So 7 through 12, I just need to take off the R value. So if we looked at the example, okay, the example problem, finally at the very bottom, it gets to that right down here, 0.8846. Now the directions are saying that they want the R value in nearest 10,000th, which is 4 decimal places. Okay, round correctly, guys. Don't just chop off every number but the first 4. Remember, for 5 or more, raise the score. 4 or less, let it rest. Okay, now, as you can tell, maybe you can't, the original homework that I would have just normally photocopied, because they planned on, the authors of the textbook planned on you doing all this work for each problem. They give like 1 page per problem, and that's crazy amounts of paper waste. So I condensed it down and put all 7 through 12 on 1 page. Again, all you're doing is pulling the R value off the calculator from the linear regression screen. Okay? And the last section. See, 1 page for every problem. We're not doing that. Okay, next I'm altering the directions a little bit. Okay? For each set of data, okay, I want you to remember this is years, so 0, 1, 2, 3, 4, 5. Don't put in the years. Okay, so for each set of data, here's what I do want you to do. First of all, enter it into your L1 and L2. I want you to go to the linear regression screen. That's choice 4 in the calculator. I want you to write down your correlation coefficient. And at that point, decide linear or not linear. Okay? And write that down. And lastly, if and only if it's linear, write your linear regression equation. If it's not linear, the equation is meaningless. Okay, there's no meaning behind an equation that's linear for data that's not linear. You can't use it to make any predictions, and there's no point to it. So I'm not going to have you write down your linear regression equation unless you have a strong enough R value to support that. Okay, so if you have a weak R value, please don't bother writing a linear regression equation because the data is not linear. Okay? Thanks, and see you next time.